Okay, we continue. Our next speaker is Christian Reiß, and he's talking about backup with Bareos and ZFS.
Okay, hello everyone. Thank you for attending my presentation about Bareos, ZFS, and Puppet. And that's right, my name is Christian Reiß, like I said. A little bit about myself. Where did we go? I'm 37 years old. I'm currently a system administrator at Simgenius. More about my company, or the company I work for, a little bit later, because I'm using the company with live data and later on in this speech. So a little bit more about myself. I'm using Linux ever since 95-ish, using a 1.3 kernel. And that's actually pretty bad. If you know 1.3, there was no make menu config or anything like that, and you had to compile your own kernel. That would take 3 hours, give or take. So that's a pain, but you also learn a lot doing that. I'm also a Bacula and Bareos evangelist, so to speak. People call me that because pretty much all the companies I've worked so far, I have converted or migrated to either of those software systems and backup systems, or, well, took over or enhanced their current setup, which I already did with my current employee, that is, like I said, Simgenius. And on top of that, I also love Puppet automatization. Now, the topic I'm going to address here, Puppet, ZFS, and Bareos, is a rather large one. So I'm assuming you guys all know Bareos. That is Bacula and Bareos. If I say Bareos, I'm of course mean Bacula and Bareos. You can interswitch them because the stuff I'm going to tell here is applicable to both software solutions. And Puppet, of course, is a rather large software suite itself. So you guys know with the Bacula director, you guys know what a storage daemon is, and you know what and where to install a FD, so to speak. So if you know that, we can a little bit continue on. We can continue on. My agenda for today is I'll give you a small history of the company I work for, not about the company itself, but rather the backup strategy we've used prior using Bacula and Bareos. And I'll give you then the solution to the problems we occurred on the migration, and of course the ZFS and what you can do with ZFS running on there. And lastly, if we have the time, I'm going to skim over the Puppet module that I wrote for all this stuff. And that's so much for the overview I'm going to tell here. If there are, of course, any questions, interrupt me at any given time. I'll try to address and answer them, whatever questions you have. Okay, a promise on my part is I'm going to do an easy listening presentation here. I'm not going to swamp you with look at my code here or anything else. No snippets whatsoever. The reason is simple. If you want to do anything I say here, you can do that because the production grade ready code is available just for this presentation here on GitHub. You can download it, install it, get it running. There is a how-to in there. It is linted, it is production ready, and we are using this setup. I'm also available for any questions you might have for implementation, customization. Contact data are at the end. So enjoy an easy listening ride. For details, look at the code, use it yourself, and implement the ideas I'm going to show you. Okay. So my company, and when I say my company, I of course, from Horn, I mean the company I work for, is Simgenius with the brand powernets.de. We are a mid-sized hosting company, so we do the usual. That is, we do web hosting, and if you know web hosting, you know mail, MySQL data, and the usual project hosting or housing. If you get any of that, well, that's us, pretty much. And this, of course, sorry. This, of course, means we have a lot of stuff to back up on a daily basis that changes a lot. And by a lot, I mean for a mid-sized company, we have a lot of files, rapidly changing files. For example, and to look at the scale here, we have several of hundred of servers across 2 data centers. And each of those servers have hundreds of customers each. Some more, some less, but in average, several hundred customers each. And each of those customers each have roughly 1,000 or more files in their home directories, and we're employing the mail tier. So each email is a file. And if you know spam, you get a lot of emails, and well, that's a lot of stuff to back up. And last but not least, we have MySQL, which needs to be backed up too. So that's a lot of I/O load for the service you're going to back up. As well as we are using virtualizations, so you have a lot of VMs that are backed up pretty much simultaneously or a little bit stripped outside for the backup routine, so you don't overload the host system. So the motivation, because we switch is, well, you understand it, is where we come from. We're coming from a time where there are no networked backups. We come prior to any production-grade ready systems, or at least they used to be, because I wasn't at that company at the time, but they actually did backup with tar. They used a tar/pipe compression somewhere, NFS share, and save it, and there you go. That's a full backup. The incrementals were actually made, and I'm kidding you not, they're doing a C time on a find, and all the file lists you generate are files that have changed in the last 24 hours. You would pipe those into tar, pipe that into a PBzip2 or bzip or gzip, what have you, and save that on NFS. And that's a lot of load for the client itself. By clients, I mean, of course, these servers that are running the customers. And think about the I/O load that is occurring alone for the traversing of the directory tree for a lot of files, for a lot of tiers, insane. And of course, the added load for the compression and the transferring to a remote host via NFS, it took ages. And of course, it's not good on either side. Server side, we used to employ 3 to 4 of those backup servers, the NFS servers, and the load was actually up on the roof. But of course, it's not renting. It did its job. It did its job good for years. And the downtimes are, of course, the compression were made on client side. And that's actually evil enough. More to that, monitoring was a nightmare. It was self-written, and it actually generated a giant HTML page, and someone had to scroll through there, look for all the red lines in there, and a red line means this server hasn't been backed up, but then what? You can't run a failed backup that should run in the night during daytime. That's not possible. The customers would dial in and say, hey, my server is like crawling. What good gives? So monitoring was, okay, it didn't work. Let's close that page and move on. Restoring, well, guess what? You had a lot of files, a lot of tar files, and you had to cat all these files through PBzip or whatever you had, a compression, and the outstream you had to pipe through tar. And there you can say, okay, extract like home, some user file, and only through going through all the backup files, and decompressing all the files, you could actually say, hey, sorry, I don't have your file there. Because there was no file list, there's no catalog. So restoring could take ages, and it wasn't actually guaranteed. Plus, on a side note, deleted files weren't handled properly. If there was a full backup, there was a file in there, and it was deleted in an incremental, well, it doesn't show up because there are no files in there. We tried several alternatives there. For one backup PC, R snapshot with ZFS snapshots, and Bacula. Now, of course, everything failed. Why did it fail? The backup PC approaches all are pretty much the same stuff. It's an rsync that goes through the root directory and syncs everything to the backup PC server. Okay, that's easy enough. But backup PC on the server side uses hard links. So on the first run, it copies all the files you have in there. Okay, the second run, it copies all the changed files and does hard links to the full backup. Now that's a lot of I/O on the server. But more to that, the incrementals going on up to 10, 15, however you want it, are all hard linked files for that. And now the fun part begins. If you actually delete or rotate a system out of there, that is, incremental is now overdue and it got to be deleted, it traverses through all the files on the file system, looks for all the hard link targets, and unlinks that. So actually the last line what it says, the backup job plus the delete job actually took longer than 24 hours on a very high-end hardware, the SSD backend. Sorry, it just piled up and it wasn't good. The ZFS snapshot approach was, we didn't do our backup PC, we did the R snapshot, snapped the entire file system for that. So we had daily snapshots we could CD into, copy the files out there, but still dropping a ZFS snapshot on there took ages, so it wasn't good. Bacula solved several of those issues right from the get-go. Backups are blazing fast. It's insane how it does it, but it does it. It has the lowest I/O load on the servers with all the systems and software solution we tried. And of course, it's also very elegant because on the server side, you can configure it in a way that all the files are saved into a single volume. Great stuff. And of course, restoring is the bliss. You TP console restore, and off you go. You got it. It just works. So, but that's not the great case here. So, but also, sorry, I missed a slide here. But also, like I said, there's no CPU load on the client side here because we don't do compression. Later on, more of that. And due to that, we can actually do a daytime backup. That's great for overseas customers. You can just do that, and no one would complain. MySQL dumps are a little bit of a different beast because you can't just copy valid MySQL over to the backup server. That would end up with invalid data at most. But, well, we have scripts for that actually dump them in the night. So to speed it up a little bit, we have at this point solved the client-side issue with a standard Bacula and Bareos setup. So far, it's pretty much standard. But we need to solve the server-side issues. Now, all the companies and institutions I've worked for so far have a very ideal and fine-tuned concept of backing up the client. They have these tweaks, system controls, they have everything in place. It works just awesome. But the server side, no one really cares unless you do tapes. And I'm not into tapes, I'm more into files. And they mostly just dump their files into an exported file system, or I've seen the wildest things there, RAID 1 software array, and but it works, but you can do it better. You know, before we consider what's actually good, let's have a look at what we need, or what our company actually needed. We need a protection against any sort of hardware fails. That is, we want to protect against hard drive fails. If a hard drive actually fails, it should continue on and just replace the hard disk, no downtime here, and off you go. We want protection against bit rot. That's interesting for those guys that have to preserve data for a long time, because all this stuff written on a hard disk are magnetized information, and magnetized information after a while degenerate and once flip to zero, and everything will, well, corrupt. So for that we need a bit rot protection of that stuff. And of course, like I said, we want transparent compression, and for an extra, because we are having customers here, we want quotas. We don't want, hey, you can use all this stuff, all the space we have on this server, just a limited quota that you can buy from us or rent from us, or that's included in your contract, what have you, and off you go. Even our own infrastructure servers have quotas because they can always go haywire, backup, recursive backup, something like there's a mount in there from a remote NFS directory and would backup that. So to avoid killing the entire servers, we have quotas per server, where we want quotas per server. Also, and this is important, we want it to totally be hassle-free. We want it a one-time setup. It should work, and it should actually work on normal hardware that's affordable to, well, all of us. Not only the top 5% on there with high-end SAS, what have you, SSD backed and stuff, but rather a system that's in the corner, that's maybe dormant for a year or something like that, whack in some hard disk and off it goes, and it should be trusted and hassle-free. No, all that is solved with ZFS. All of that. Okay, and Bareos. And so let's have a quick look at the points I said with the feature set of ZFS. And one of those is, of course, protection against data corruption and continuous checking. You can read yourself. This actually just means, very much simple, that it does checksumming. A little bit tuned down, it means the smallest amount of data stored on the ZFS has a tiny checksum bit on there. Now, several of those checksums are, again, checksum on a higher level, and again on a higher level, and so forth, up until the root node. So you have a path of checksum you can traverse and calculate up to the data you need, and if any part of that throws an illegal checksum or data is corrupt or something, you know that this part is not correct. It has bit rot or whatever, hard disk failure or not. And since we will be deploying a RAID system or RAID-like system, you have another copy of the data. You check the checksum tree there, you notice, okay, this calculates right okay on top, so you can copy the data file and the checksum information over to the faulty drive, and off you go. This actually, combined with smart dechecking, eliminates bit rot corruption, and that's actually pretty cool. Now, I said RAID-like stuff. The ZFS has RAID Z, RAID Z2, RAID Z3, and what have you, so you can actually lose 2 or 3 hard disk, and it will continue on. You can check it like a RAID 5. A RAID Z2 is like a RAID 5-ish, and like RAID 6 is like a Z3 and something like that. Not getting too technical here, but this is pretty much the same stuff. And the great and awesome thing here is that you don't need a RAID controller. Actually, the guys from ZFS say, don't use any sort of RAID controller. Give us the pure hard disk and we'll manage and go from there. So you are free of RAID controller hassle. If you set up a RAID controller and the RAID controller dies, you are still bound to that manufacturer, because try to get a RAID up and running from a different manufacturer, Three-way for example, and get it running on an Adaptec. Good luck. With that stuff, it just works. You just yank out your disk, put it in some whatever you have, a notebook, if you with data controllers on USB, you continue to get it to work. So that's actually working. Now, I only mentioned this on a side note. It has very, very large capacities, so you can scale all you want. No one here will ever reach the zettabyte file system, and so it's zettabyte file system. Good luck with that. We also employ or use the efficient data compression. Now, it does support several types of compression, from gzip1 to gzip9 and what have you. There's one very cool one that's actually very fast, and you can look it up in the code if you want, but that is really, really, really fast. I'm going to show you the benchmarking or some benchmark results later on, but this is really, really cool. And you can also do a complete snapshot on the fly on this server. So you're testing something out, you log in onto your server, your backup server, your SD, and you want to do some wild things there. You can just say ZFS snapshot, and it's snapshot. You can always revert back to that state. It's actually not big of a use in my use case and with the Puppet code, but it could open up possibilities that I'm not seeing. Still, it's there. For example, if you do R snapshot, do a snapshot, a real ZFS snapshot, do an R snapshot, and so on. So it actually does work. And a great thing also is that ZFS is freely available and already included in most current distributions. If you got an Ubuntu, okay, who runs a server on a Ubuntu, but still the possibility is there, and 16.04 and up, ZFS is in there. Just install it and off you go. It's also available in default in future Debian releases. Install and off you go. And for all the rest, like CentOS 7 and 6, and your mostly error of choice is you can download a distribution via ZFS on linux.org. It's repositories for your favorite OS. You just install and off you go. And last but not least, the ZFS is so popular, it also is being used by, for example, FreeNAS. Okay, FreeNAS is used FreeBSD as a base, but still, if you use this FreeNAS storage appliance, I suggest you do have a look at it. It's really great. It's using ZFS as its main backup storage. It's really fast. It's blazingly fast. Get a ProLine micro server, and you have a very good NAS for a very cheap price. Now, if you really want to install the ZFS, it's a matter of, like I said, you install the package, you do a yum install ZFS or apt-get install ZFS. It installs kernel by default, or some kernel sources by default, reboot once to get the kernel modules up and running. You can do a mod probe, but it's recommended to do a reboot, not from me, but from the ZFS developers. And there you go. You have got the ZFS working already, and you can work from there with zpool create, and you got a working zpool to get going. So these two commands here are actually all you need to get it up and running. No? So if you have a working Bareos director or server, actually server part, and you want to convert, this is as easy as that. Okay, so a live example from us is we found this very old machine actually lying in a data center that was turned off and dormant for some time. It's very low end. It has 2.5 gigahertz with a single 8 core. There's not 16 logical cores, it's really 8 cores in total in top. So there is a really CPU bottleneck. It was used by myself as a testing setup for my Bareos Puppet module with the ZFS stuff. I wanted to check if it actually works, and we wanted to buy a bigger machine for that, but turns out I didn't need. It actually is totally sufficient. We have 32 gig of memory, which was already in there. We can use a lot less, at least 8 gigs is recommended, 16 also, hey, the more the merrier, so be sure it's ECC RAM because you can need to protect your data for bit flips in there because that can corrupt an entire ZFS pool. Look it up, ECC with ZFS, it's a must-have. Okay, and last but not least, the system is installed on an SSD drive. So the MySQL data for the director, which is also run on the storage device server, it's a two-fold server, is running from an SSD because our MySQL data has reached nearly 300 gigabytes and counting due to the high file count we have in there. And writing and reading the SQL data files really is a bliss if you have an SSD drive. It cuts the backup time in half. That was actually a bottleneck. No more is, but still. And we have employed 22 times 4 terabyte Western Digital Reds. Now this is not an advertising. I'm just stating we're using these cheap ass disks here, consumer grade disk for production environment, because it just works. You can use it, you stick it in there, they are slow moving, they are like 5 or 7K, they have a tiny cache on there, but it's exactly what ZFS need. Tiny, stupid drives that are actually not very fast, tons of them if you want, and bam, there you go. I also have a 1 gigabit of a network connection in there. No, that doesn't sound much. Like I said, it's a test setup. It was. Now, with this setup here, I can do 35 servers backing up simultaneously on this thing. Now, really, yes? We have a host bus adapter that's I think a 22 and a 6 device. So we have 2 expansion cards that actually just passes the SATA drives right through the Linux system. We have dev SDH to dev SDLM, I don't know, rather large count there. But it is working. Yes, please. We are currently employing CentOS, but don't be afraid. The Puppet code can do Debian and CentOS, and I have integrated my own personal home PC for backup purposes only, and it took me a mere 3 minutes to get a new OS in there. If you fail or need another, just contact me. I'll get it done. Okay, so the CPU and Max are. CPU and NIC are maxed during the night time. That is, those two are actually the bottleneck here, and we can do backups of 35 servers simultaneously. It's a matter of concurrent jobs in the director. It's the only limit we have employed in the entire setup, and it works like a bliss. And with the cheap server setup I shown you, that's 900 Mbit of compressed data. Now keep in mind, those 900 Mbit are consisting out of very small files, tiny files, many files of them, shoven directly and uncompressed to the server, which does transparent compressing, as well as rate checking, as well as the CRC for the ZFS, and a lot more. And there you go. And 8 cores. You can, and this is the beauty of it, scale it to boots. You can have, of course, a bigger CPU, to put in another NIC in there, another network device, whack them together with a big bond device, have a switch that can do that, and off you go. You have a lot more firepower. And not only that, increase the storage director count by 2. Have 2 of those, 3, whatever. It scales, and it's like medium scale hardware. It's not high end. It's 8 cores. Come on. Okay, to have a look at the load average, this is an Ichinga graph from a random day, and you see this is 8 p.m. And at 8 p.m. we do the MySQL data dump from the director. We want to back up the Vale MySQL with MySQL dump, pipe it through bzip2. This explains the high load here, and it's finished at around 9-ish, I guess. And this is so we can restore the entire thing with a import of the MySQL data, and we are up and running again. The entire setup, like I said here with Puppet, is completely disaster protected, given that you save the, of course, data files for your clients as well as the bootstrap files somewhere. The rest comes from Puppet, and it regenerates everything like, well, perfectly. And I did it several times. I reinstalled it 2 times this year for upgrades. One we switched from CentOS 6 to CentOS 7, and I just installed it anew, copied switched the drives around to the new chassis, and let a Bacula run, Puppet run, sorry, and Bacula run off like nothing actually ever happened. Now this is the start of the backup. We start at midnight and finish at around 6 a.m.-ish. And you see this line here, it's a lot of 1.0. So all cores are maxed, but not overutilized. So just scale it if you want to. You can do 60, 70, whatever, with cheap systems. Now, I am actually doing one quota or one data set per server. That is, I have 3 servers, for example, and each server gets its own ZFS data set. It's an own file system, and not entirely the same, but you can see it as an own file system. For example, the server D125 is actually on /Bacula storage, and there you have it. It's FQDN, it's the folder name, and in there I did an DF disk usage. You see the quota of 4 terabytes. 1 terabyte is probably used, and 3 terabytes are free. Okay, that's not actually big news, but that's the setup I'm employing with hundreds of servers, and it's working perfectly. Especially if you need to delete a server, you just wipe the entire directory clean, and no traces are left behind. Now, inside of a directory, you see the files. I'm doing 1 file per volume, 1 job per volume, and every server has its own 3 pools. Every server has its own full, differential, and incremental. And you can see here, I marked it red. I hope you can see it. The colors aren't exactly perfect here. You need these files to restore the most recent backup for this server. The rest, well, they are there if you need another timestamp, but those files are actually there. And written, and you can pass through them, look at them if you need to, like, and can I wipe them? I have a script that traverses all the trees, checks the MySQL data files. If this volume is actually in the database from Bacula, checks if there's a job for this device. If not, and it's maybe unknown or expired, it actually deletes that stuff, and off you go. You even have a cleanup of your hard disk. Now, I said compression, and it turned it on. And you can see here, for those 4 randomly selected servers, that the compression is actually quite good. It's 2 times on this server. So compression works good, and you can actually increase it by yanking and cranking up the compression algorithm employed with the ZFS stuff with 1 single command. I suggest you don't do that because the gain from a higher compression ratio is really, really tiny compared to the amount of CPU power you had to push in there. Okay. Regarding the compression ratio, you can see for these 2, again, randomly selected files, that you save around 30% of your net written stuff. That's good. 30% save for actually pretty much no cost or no extra hardware. Let's take that. And if you consider how many terabytes you have, 30%, well, it's quite nice to have. And on a side note, if you want to do this, deduplication on ZFS does not work. Even if you have identical servers, a lot of identical servers, the volumes that are written on the storage server are different because there may be one tiny file in there that squeezes the volume up a little bit, and the entire volume is deduplicated on the ZFS. So even on identical servers, the volumes are not, but you use up a lot of memory, and I'm talking a lot of memory. So deduplication does not work. Do not attempt this. Do you have a question? Yes, of course. No. Yeah, we tried it in entirely. We tried the same. We actually turned on deduplication for several servers. Didn't work, really. I know, it's just in theory, yeah, of course, but I'm talking practical stuff here for practical systems. You want to get out there, you do your job, and in theory you can save. Doesn't really help you in your field because in theory it doesn't save. So, summed up, ZFS gives you the ability to not use any more RAID controllers. Throw them away. That's a waste. Okay, and it's even slower. Plus, you're no longer bound to a RAID controller in there. You have a working defense against bit rot. You have a defense against dry faults, asterisks. Because if there is a pipe burst in your data center, you lose the server, like we learned. Okay, and of course, compression is done on the server side, like I said. And quotas, like I've shown you, are also possible. And all this I've shown you is done without a single hack, additional script, or whatever. It works out of the box, and you can do it with your stuff without me giving you any single line of code. I will, of course, so you know how to do this, but it actually works like this. Okay? So this actually, I'm looking at the time, concludes the ZFS part for this. And we're now moving on to the Puppet part. Okay. The Puppet part, for who doesn't know what Puppet is? Honestly. Come on, everyone knows? Okay, one hand is enough. Puppet is a configuration utility. So you tell the Puppet server, okay, I want these packages installed. I want these configurations like this, and do, I don't know, this mode on this directory like so. You would define a final stage of your server like you want it. And it enforces that in regards of whatever you want and whatever you have. It just works. So in order to actually, it's able to do that, you need to have a module, like a Puppet module. So you can do whatever you want in that module, but mostly you want, of course, a backing up server. Okay, small interaction here, but a Puppet module, or my Puppet module that I wrote, is of course similar to most of the Puppet modules out there. Of course, it does backups. Of course, it configures the directory, the storage, and the clients. Okay, so if you install it, it will do all this stuff. I'm only showing you the stuff that I'm doing different or on top of the normal modules that you will most likely guess it does. So my module, like I said, does the usual, okay, what I just said, let's skip that. And what I do different is, or maybe different is, I do independent pools for all the servers. So you have pools times server times 3. Like you have 100 servers, each server gets 3 pools, so you have 300 pools in there, and it's actually a large amount, but it works, and it works very cool, because you can, if you have a test server, you can delete or drop a pool, and it's gone, you can start on fresh, just an example of what you could do. And of course, all these files are based in its own ZFS data set, so if you don't need it anymore, you can destroy that stuff. And each server that you configure with Puppet, of course, has limited bconsole shell access. So if you haven't used ACLs before, you pretty much will now, because if you do type bconsole on any given customer server, that bconsole can restore, backup, and do all the things related to this server. You cannot restore files from one server to this server you're connected to, or vice versa, but you can run backup jobs for the same server or restore files for the same server. You are in your own little shielded environment, so to speak. You can disable this at all if you don't want your customers to have access to bconsole, even the limited ones. You can disable that. Via Hera, you just set a simple variable and it's gone. and it's also documented how you will do that. And second, each server has its own device, so we can actually mount several volumes simultaneously from several pools and do these simultaneous 35 and more servers at any given time. It's a workaround, but it's actually great. Now, lastly, it's fully monitored by Ichinger Nagios. I want my backup system to be totally silent. I want to install it once today and never hear from it again. And I want it that way that if I don't hear from it again, I know it's running. If it's failed to run or doesn't report, it should raise an alarm and I know about it. It should come to me, not the other way around. It should work for all servers and all configurations. If it doesn't alert me, not the other way around. And of course, we wanted a fully automated system. If I added a new server, it's a matter of signing the Puppet certificate and never hear from it again. It should install the repositories for the current Bareos installation, which is also configurable via the Hero Puppet fact. You can it installs the configuration and whatever you have. Plus, and this is important, we want a non-destructive installation. Now, what is that? CentOS, for example, had a bug. Had is in past tense that the ZFS module does not get recompiled if a new kernel got installed. So you type in yum update, it says, hey, I got a new kernel, sure, install it, reboot it, and your pool is gone. Not destructive gone, it's still there, but you had to manually reinstall the ZFS tools, and then it works again. It's it's a bug from Red Hat. There's a Red Hat click this, type this, and it's solved thing, and it's actually solved in upstream now, so you won't have this problem anymore. But if we do a destructive installation, it would look for a free or available disk, install a Z-pool in there, wiping all your data clean, and off you go. Not good. So after installation, you need to type in 3 commands, also documented, just type it, and you're off you go. And also is the soft removal. If I delete a server from Puppet, the configuration should be cleaned. It should no longer do any sort of backups. It should be silent. But the data files and the bootstrap files should remain in place. Why? Because the Puppet DB system that contains all the Puppet configuration might actually fault at some point. And if it does, it reports, sorry, I have 0 servers for you to back up. And the director would go and wipe its entire slate clean with all your backups along with it. So that's not good. Soft removal is way better because whatever the Bacula does and removes, you can reinstall by running a Puppet run. So it's as simple as that. Now, on top of all that, I want, like I said, 1 file per volume. I love it because you know that if you delete this file, you only wipe this single job and it's clean, so to speak. There are other approaches, but this is what shown me in my profession so far the best results there are. And in addition to the monitoring, the usual monitoring, I want to monitor the last backup that ran, and I want to know that the last backup actually did run with whatever exit code. If their exit code is not 0 or whatever warning, I want to trigger an alarm. If it's okay, then be silent about it. If it doesn't report, alarm me. If it's green, I must be sure it's okay. So that's actually a very good thing. Also, I want monitor the MySQL dumps, because what good use is a customer server where you don't have MySQL dumps, okay? So let's back up that as well. And we check for the last valid full backup. The setup I'm showing you does increment or increase the backup level from whatever to full if there isn't a backup within the last 30 days. And this alarm also gives us an alarm if there are no valid backups in the last 30 days. So if these checks are all green, you know you have a valid full backup, the last backup has been run, the MySQL data has been backed up, and all services are running. It's as easy as that. So no alarms, it's okay. And of course, it's a freshness check. So if the Ichinger server does not receive any sorts of results from whatever result or whatever we monitor, it will trigger a freshness alarm. So we even check that it does receive alarms at some point. So there are no stale okay warnings and whatever. And of course, there are complete random passwords generated for each connection. Each server and each client, each backup, whatever you have, has an own randomly generated password. You can supply fixed passwords if you want, but there is really no need because you don't really touch any of this by hand. It just seemed to work like that. And an additional very nice thing is the fd.conf file that you need for the file daemon is also placed on the Bareos director in a special own directory. Why is that? It's pretty simple. Disaster recovery in 2 commands. You can launch a system rescue CD, and I don't mean any, but the system rescue CD that you can download, the Linux-based rescue CD, and just launch it. It has a pre-installed Bacula file daemon in there, and you just copy this configuration over there, up with the IP, and you can restore your entire system. And we tried it, we used it in a real-life scenario, we got an up-and-running server by doing just that. So it's a really great thing to have. And of course, the option to override IPs. With NAT setups and routers in there, you can, or the IP might change from the view from the director. It sees the public IP, but the client that's actually connecting has a private IP, so you can override all that with the HERA stuff. While talking of HERA, HERA is the configuration tool per host, so you can do a very fine-grained access or configuration in there. You can also override, hello? No, there we go. You can also override several other things. I've documented them all, like I said, but here are some more. Of course, you include and excluding of files. By default, it includes all and excludes the usual temp files and whatever you have. But I'm approaching this with the let's back up everything and not lose anything behind, rather than having forgotten something and tell your customer, sorry, I didn't back up your application that you installed in a non-valid or non-real directory. So let's skip that and rather take the additional space we need for that. We, of course, have the accurate thread that's default by yes. So deleted files are monitored correctly. This is actually overridable because there might be systems out there that cannot run Bareos, maybe some very old stuff or pre-installed stuff or stuff you don't have access to, like Bacula, old Fedora stuff, and it does not handle the accurate flags. It would just panic on connecting, or so you can disable that in there. And of course, the one file system flag. It will not traverse into mounted directories by default. In this case, you can override if you want to, but still. Now, I talked about the monitoring, and this is a live example of the monitoring, and you see the different alarms. The Bacula FD daemon is, of course, the process itself that the Bacula FD is running. Of course, this should always be green. The last full backup, and you can see here, okay, the full backup is done okay within the last 30 days. If it doesn't receive any sort of confirmation or anything else, it would turn red with a stale check, or of course, if it's over the 30 days, it would actually state it here. The last backup is the next line. It would say how long it actually did take to complete the last backup job, and at what time it did complete. And we have a check for the MySQL databases. As you can see here, nearly 900 databases were dumped and dumped okay. This is a very fragile check. If there are even the smallest error in there, it would turn to a warning. It's not like, okay, you can not dump 10 databases and still be okay. One database not dumped or any warning whatsoever, it will turn not green. It will turn yellow or red. So if it's green, you know your server is perfectly backed. And you see here, of course, the quota. On the ZFS, 14% here used, and I'm lazy, of course, we do restores, and if you do restores, you get the /Bareos or /Bacula restores directory, and sometimes it's not cleaned up, so this actually checks that there is this directory, and if it's there, it raises a warning, so no more space wasted in there. And last but not least, the Puppet module also does install the web UI completely and without any doing. You can, of course, disable this if you don't want to, but by default, it installs the Bareos web UI, complete with access information, and it all just works. And that's it. Okay, this actually would sum up my presentation here. Guess I'm inside the time frame here. Thank you all for your attention so far. And like I promised, here are the contact information and the GitHub available, or the URL where you can download the current code. As I guess or heard, the Puppet slides will be made available to all of you at the end. So it should be easy to get these informations if you don't write it down right now. And like I said, if you have any problems or if you're implementing or have any questions, I'm available via my email. Okay, thank you. And are there any questions? Yes.
One moment, please.
Do you configure the old clients also via Puppet?
Yes. The Puppet module does configure all clients. I think our oldest client is actually a Fedora Core 6. And that's 2000-ish. So, yeah. And again, if you have a problem, I can implement. So, if you need like a Gen 2 or something like that, I can do that. Puppet is very easy and forgiving in that. I guess the microphone needs to pass.
I just looked into your repository and I saw you're using Xen Server 6 too?
Yes, of course. And it does backup.
Okay, that's very interesting. We have to look.
Because you get a seg fault.
Okay, it doesn't backup. Okay, I see.
And it does backup, and I was asking you because you were getting a seg fault error on a connection. It's actually a problem with Xen Server and a patch 23, I guess, and this patch 23 updates the crypto libraries on the Xen server, and in that the Bareos doesn't start anymore and the Puppet doesn't start anymore. You have to implement a patch for that. It's simple. I can show you.
What version do you use?
For Xen server?
Yes.
6.5.
Okay.
But it's down all to 6.0. So it's a reproductive. You can actually reproduce this set error if you run the Bacula FD or Bareos FD with the debug flag in foreground, connect and run a backup job, and you'll see it will seg fault, and it's due to the crypto SSL. Oh, all the way in the back there, sir.
One moment.
And yes, I'm employing Xen server is supported 6 to 6.5. We're using CentOS in 5, 6, 7. Debian is supported, and like I said, I can implement many more. It should be easy.
So I'm surprised to hear that, and I also see the faces of my colleagues. They are also surprised. It would be nice, May, if you think about to contribute it or to make it public available. So. What you told about Xen server stuff?
Yeah, I did make it seem public. I did write a blog post, and if you Google for Xen server Bareos seg fault, I'm like the first page. But I can submit, of course. Yes.
So may on our mentors, or would be really nice. I think all for the others.
I'll get in contact. I'm sitting 2 chairs next to you. I'll get in contact, of course. Any more questions? Okay, then thank you for your attention, and I hope you will enjoy ZFS.